LFS Large Fiber Splicers and GPX Glass Processors use resistive filaments to splice or process glass fibers with cladding diameters up to 1.25mm or 1.7mm. This video will demonstrate how to use the movement control bar and the alignment guides in the FFS3 software to manually gap and align fibers before they are spliced. If you have not already watched the previous videos about the features of the FFS3 software, it may be helpful to click on the annotation and view these first. Although the FFS3 software is capable of carrying out either fully automated or semi-automated splices for standard fiber types, more advanced users wishing to carry out process development for new or novel fiber types will find that performing manual splicing using the movement control bar to position fibers will provide an extra flexibility and functionality that is helpful when developing a robust process. In automated splices, the unit autonomously works through a splice process defined by a specific splice file. Although the splicing method covered here is manual, to provide a reference for the individual steps of the splice process, it is helpful to ensure that a splice file for the fibers is loaded and displayed in the splice process window. When fibers are loaded into the unit, the camera is usually at the home position, which will mean that the screen in the user interface is dark. Click the Load Fibers button on the main toolbar to move the fiber holding blocks to the predetermined load fiber positions. If set up correctly, this will ensure that when the camera is moved to view the fibers, the tips will appear on screen but not be overlapping. Strip and prepare your fibers and load them into the left and right fiber holding blocks. To perform the first step of the splice process, use the camera bar to select Front View. Once the view is selected, the lens will move forwards so that it is positioned over the fibers and the fibers will appear on screen. Now focus the right fiber, which must be done in front view, by clicking on the autofocus button in the camera bar. While the autofocus process is happening, the other buttons in the interface are greyed out and can't be selected. Now the right fibre will need to be aligned to the left. The vertical position of the right fibre on screen must be adjusted in the front view using the right pivot control. In the View menu, select the Crosshair Alignment Guide. Place the crosshair on the upper edge of the left fibre to provide a reference line for aligning the right fibre. Select the appropriate radio button on the right pivot control and use the arrow keys to adjust the position of the right fibre so that it is aligned with the crosshair. Once the right fibre is roughly aligned, now move on to the next step of the splice process, focusing the left fibre and then gapping both fibres. If you want to keep the image of the fibres uncluttered, the crosshair can be removed. The left-hand side fibre must be focused in back view. Use the camera bar to select Lens Back. Now focus the left-hand side fibre by selecting Autofocus. To help gap the fibres, use the View menu to select the Alignment Guide. This brings up two vertical lines on screen. The distance between the two lines is the pre-gap distance that is set in the splice properties. By convention, fibres should always be gapped in back view to ensure a consistent approach. The fibre holding block controls on the movement control bar can now be used to move the ends of the fibres to these guides, thereby gapping the fibres. Use the radio buttons and arrow keys to position the left and right fibres so that their front edge is on the alignment guides. If you overshoot the position you are aiming for, it is important to reposition the fibre while compensating for motor backlash. This ensures accurate movement and position for any following motor moves. Do this by moving away from the target position by about 30 to 40 microns. And then reapproach in smaller steps. Compensating for motor backlash is crucial when gapping fibres, as this ensures the push and hot push distances during the splice are accurate. Accounting for motor backlash for the vertical movement of fibres is less critical unless you are performing active optical alignment methods or scans. The next step is to align the left fibre to the right using the left pivot control. The vertical position of the left fibre on screen must be adjusted in back view. Deselect the alignment guides and select the crosshair guide. Place the crosshair on the upper edge of the right-hand side fibre. Now align the position of the left fibre with the crosshair using the radio buttons and arrows on the left pivot control. Now that the fibres have been gapped and aligned once, the next step of the splice process is to check the alignment in both views and realign if necessary. Select front view to be able to realign the right fibre. As before, use the crosshair positioned on the top of the left fibre and the right pivot control to align the right fibre to the left fibre. Now return to back view. This will enable the alignment of the left-hand fibre to be checked. Use the crosshair lined up with the top of the right fibre as a reference guide. If necessary, use the left pivot control to align the left fibre to the right. An iterative approach has been taken and the fibres should now be gapped and aligned in both the back and the front views. Note, when the fibre tips have been gapped in back view and are then viewed in front view, it is normal for the fibre tips to be misaligned from the alignment guides. The fibres can now be spliced together. On the main toolbar, click the Splice Only button. This executes a series of motor moves for the camera, splice head and right fibre holding block. Power will also be applied to the filament, enabling the fibres to be spliced together according to the parameters in the splice file. To view the splice, select the back or the front view. The camera lens will move forwards and the splice will be displayed on screen. Back and front views allow the splice to be seen in orthogonal side views. For standard fibre types, fully automated or semi-automated splicing as offered by the FFS3 software will generally be sufficient. However, knowing how to use the movement bar can be helpful when carrying out advanced process development or for recovering a splice if a problem occurs during an automated process. If you have any questions or concerns, please email us either at techsupport@thorlabs.com or vitran.uk@thorlabs.com.